randomly selecting a single jar, finding the contents to weigh less than 16 ounces, or randomly selecting 10 jars and having the average less than 16 ounces. And then we're going to find the probability of each event above. So I want you to think about that. Think about that. Okay? What do we think? What do we think? Make a prediction first, and then in B, we'll verify the prediction. Okay, we'll provide evidence for what we thought. Or maybe we put it down incorrectly, and then we come back and disprove what we thought. So what's more likely? Randomly selecting a single jar and finding it to weigh less than 16 ounces? Or randomly selecting 10 jars and having the average weigh less than 16 ounces? So I'm interested to see what you think about your predictions. Okay? The idea behind this is that as your sample size goes up, your variability goes down. Okay? So as your sample size goes up, okay, we expect the standard deviations to go down. We expect the variability to go down. So which one's more likely? Randomly selecting to weigh less than 16 ounces? We would expect the 10 jars to be closer to the mean. Variability goes down, means your values are closer to your mean. Okay? So let's look. Let's do the work. Okay? So let's do for the first one. So the probability that it's less than 16. So the probability that X is less than 16, this is situation 1. This is a single jar, so we'll write over here, single jar. So our data value is 16, so I gotta find a z-score. Okay, so my z-score is gonna be my data value, which is 16, minus the mean, which is 16.1, divided by my standard deviation, which is 0.15. So when I do that, let me get my calculator. So I do 16 minus 16.1, and I get negative 0.1, divided by 0.15, negative 0.6667. That's my z-score. I want it to be less than that, so I'm going to do norm CDF, negative 999 to negative 0.6667. And we're going to find that probability. Second vars for dister, my distributions, negative 999 to I put a subtraction sign. That's a big mistake. That's not going to work. But when I do that, I get a probability of about 25% of the time. 0.2525. Okay? 0.2525. All right, now let's do the next one. So in this one, okay, when I go to find my z-score, I'm going to use my standard deviation, but when I use this one, okay, the reason that was 0.15 was because my standard deviation is equal to the standard deviation divided by the square of the sample size. Well, my sample size was 1. That was my sample size, a sample size of 1. So I took my standard deviation, which was 0.15, and I divided by the square root of 1, which is just going to be 0.15. But when I do it over here for 10 jars, okay, for 10 jars, I have to take that 0.15 and divide by the square root of 10, because that's my sample size. Okay? So when I do that, I have 0.15 divided by the square root of 10, I get 0.047. So now when I go to find my z-score, it's still going to be 16 minus 16.1 divided by, but now it's going to be 0.047 because my sample size is 10. Don't forget, this is your formula. Okay, this is your formula. We didn't have to worry about it here. Your sample size was 1. Here we have to worry about it. My sample size is 10. So this is going to be negative 0.1 on the top divided by 0.047. So negative 0.1 divided by 0.047 gives me negative 2.13. Negative 2.13. So now I do norm CDF negative 999 to negative 2.13. Second vars for Dister, negative 2.13. Wow, look at that, huh? 0.017. That's what we thought would happen. That's what we thought. Okay? Which one's closer to the mean? This one's closer to the mean. This one's further away from the mean. So which one's more likely, getting it less than 16 ounces? It's more likely that you get that with just 1 when your sample size is 1. Okay? When your sample size is low, you have more variability. When your sample size is high, your variability goes down. The chances of having extreme values goes down. And that's why this worked out that way. Okay? So that's going to wrap up at least this part. The next video we're going to start talking about is the central limit theorem. Okay? But this is probably a good spot for me to stop.